Graph Theory Class 1 Video 2. In this video we're going to look at some examples of graphs which arise in the real world. These graphs model real world situations. So let's begin. The first example I want to talk about is a graph which models friendship. Okay, so the objects of my graph are going to be people. So I'm going to name my people the following: Alice, Bob, Charles, David, and Eve. So these are my people, and the relationship is just friendship. So that means that there's an edge between two objects, two people, if they're friends. Two objects, like, which are people in this case, if they are friends. Okay, so one possible situation for this could be the following. I'll draw 5 vertices and I'll label them Alice, Bob, Charles, David, and Eve. And if I just start drawing lines, like this line here indicates that Alice and Bob are friends. Maybe Alice is also friends with Charles and David and Eve. Alice is friends with everyone. Okay. Maybe Bob is friends with Alice and David. Charles is also friends with David. And maybe Eve is just friends with Alice. Okay. So this is my graph. It conveys the information of who is friends with who. It tells you the friendship status of all these people in a really nice condensed way. Okay. One thing I want to point out is friendship is a symmetric relationship. Friendship is a symmetric relationship. And what I mean by that is, if Alice is friends with Bob, then Bob is also friends with Alice. It goes both ways. Okay? So this is a graph, and we call this a undirected graph. And it's because the edges don't have directions. We'll speak more about this notion later on. Okay? Let's move on to another example. So how about this time we talk about the relationship of fancy. So my objects are going to be the same. Alice, Bob, Charles, David, and Eve. But now my relationship is fancy. Okay, and what I mean by this is there is an edge from, let's say, Alice to Bob, if and only if Alice fancies Bob. Okay, and notice now in this definition I say from Alice to Bob. So now my edges have some sort of like direction to them. Let's just draw a picture and see what happens. Again, I'll label the vertices. Alice, Bob, Charles, David, and Eve. Okay. And maybe Alice fancies Bob. So I draw an edge with an arrow. And it's important I have the arrow now because I need to indicate who fancies who. Alice fancies Bob. And maybe Alice is lucky and Bob also fancies Alice. Okay? I need to draw both arrows, right? Because it's two separate pieces of information. This is more complex than friendship. Friendship is a symmetric thing, but fancying is asymmetric sometimes. Maybe Alice also fancies Charles, and Alice fancies everyone. Okay, so Alice is attracted to everyone. Bob is just interested in Alice. Maybe Charles fancies David, and David fancies Charles, and Eve doesn't fancy anyone. Okay, so this graph represents who fancies whom. Okay, so things to note from this graph is fancy is not a symmetric relationship. I mean, I imagine some of you are aware of this fact, right? Just because you fancy someone does not mean that they fancy you back, okay? It is not a symmetric relationship. So you can have situations like this situation right here, where Alice fancies Eve, but Eve doesn't fancy Alice back. Okay? So fancy is not a symmetric relationship, so the arrows are important. And unsurprisingly, we call this a directed graph. Okay? The first type of graph we looked at, we called it an undirected graph, and there are no arrows, no directions. When there are arrows, you call it a directed graph. Okay? One more thing I want to mention is if we examine the situation between Alice and Bob, we see that Alice fancies Bob and Bob fancies Alice. Okay? And I've drawn two arrows. That's perfectly a legitimate thing to do. But it's also legitimate to do something like this, to do a double-headed arrow. Okay? So there are two ways of conveying this information. You can either do this situation here, where you do two arrows, or you can do a double-headed arrow. Either way is fine. But I think for style purposes, you shouldn't mix on the same graph. So what I've done here, it upsets me style-wise, okay? I should either always do this style or always do this style. But I'm doing this for instructional purposes, okay? That's a fancy graph. Let's move on to another type of graph. So maybe this time I'm going to look at the relationship of magnitude of dislike. These are getting more and more complex. The objects are going to be the same. This group of people, Alice, Bob, Charles, David, and Eve. And now the relationship is just going to be the magnitude of dislike. Okay, so I'm just going to dive straight in and draw a graph. Alice, Bob, Charles, David, and Eve. Okay, and dislike is a asymmetric. It's not necessarily a symmetric relationship, right? So I'm going to need directed arrows. So I can draw an arrow like this. This means that Alice dislikes Bob, but also I want to convey the magnitude by which she dislikes Bob. So I'm going to write the number 9 there. Okay? And what this means is that somehow, in some measure of dislike, Alice dislikes Bob a level 9. And maybe Bob dislikes Alice, but only dislikes Alice like a level 7 or something. Okay? So Bob dislikes Alice less than Alice dislikes Bob. Maybe Charles dislikes Alice, a level 5, Maybe David dislikes Alice. Just a 1. And maybe Eve dislikes herself. Okay, Eve dislikes herself, a level 4. That's what this arrow is conveying. So this graph here, it tells you how much each of these people dislike one another, including possibly themselves. Okay, so again, things to note: dislike is not symmetric, and the numbers tell you how much they dislike. The other person. Okay, and this is called a weighted directed graph. It's weighted. The weights are the numbers. So it's weighted because I wrote the numbers everywhere. They tell you how the weight of that particular edge. Okay. So this is an example which tells you the magnitude of dislike. That's the end of this example, and it's the end of this video.